Hello friends, welcome to Shibi's chemistry classes. Today's topic is periodic properties. Periodic properties. See, in the previous video, we have completed periodic table and salient features of periodic table. Now we have to study periodic properties. So first we will define it. The properties that reappear after regular interval, that is increase or decrease as we move across a period from left to right or down a group. So first we will try to understand what is the meaning of this definition. The definition says the properties that reappears after a regular interval, that is, it shows either an increase or decrease as we move across a period or if we move down a group. We know that the horizontal rows, they are called periods, and the vertical columns, they are called groups in a periodic table. So in periodic table, elements are arranged in periods and rows. So these elements have some properties, and that properties shows some regular trends. And if we move across a period, that properties either increase or decrease, or if we move down a group, they show some trends. So that is what we have to study here. And this phenomena, the trends that we are talking about here in this definition, if this phenomena is occurring, this is called periodicity. Periodicity. And what is the cause of this periodicity? Cause, why it happens? It happens due to the recurrence of same electronic configuration. If we are talking about electronic configuration, that means we are concerned only about the outermost shell or valence shell electronic configuration. So let's take some example to make it more clear. So we know group 1 element, they're hydrogen, lithium, sodium, potassium. Atomic number 1, 3, 11, 19. Configuration is 1, 2, 1, 2, 8, 1, 2, 8, 8, 1. So this is the configuration of first group element. So if we see this configuration, you can see that it has one electron in its valence shell. All the elements that belongs to a particular group, we know that they have valence shell electron same or same number of valence shell electron. Here in this case, since they belongs to group 1, so they have one electron in their valence shell. So that means these elements have some properties in common, or that properties either increase or either decrease. So, so that means these elements have some properties in common. Similarly, if we take elements that belongs to other group, if elements belongs to second group, then they will have two electrons in the valence shell. So they will also show some variation or some trends of properties. So we have to see what those properties are. Let's see. First we will see atomic size. This is the structure of an atom, and we know that this is in the center there is a nucleus that is having positive charge, and electron revolve around the orbit, circular orbit, and this is the outermost electron in this particular case. In this structure of atom, this is the outermost electron. It has two shells and a centrally placed nucleus. So when I'm talking about atomic size, it is the distance between the center of the nucleus to the outermost shell. This distance, this is atomic size. And if we add more shells to this, then the size of atom will increase. So it depends upon two factors. One is number of shells, and second one is nuclear charge. So how these factors affect the size of atom? Number of shells, as I already said, if we increase the number of shell, the size of atom will increase. For example, lithium, atomic number 3, 21, sodium, atomic number 11, 281. From this configuration, you can see that lithium has 2 shells and sodium has 3 shells. If you make the diagram, structure of atom, 2 electron, 1 electron. Here 3 shells are there, 2 electron, 8 electron, 1 electron. That means as we increase the number of shell, atomic size will increase. The second is nuclear charge. What is nuclear charge now? The charge which is present inside the nucleus. And we know that inside the nucleus we have two things, that is proton and neutron. Proton is positively charged, neutron is neutral species. Neutral means it doesn't have any charge on it. So if it is not having any charge, that means the overall effect will be of positive charge. That is why nucleus is positively charged species. Okay, so this nuclear charge, how it affects the size of atom? Say if we increase this nuclear charge, what happens? It will pull. The pull of the force of attraction between this nucleus and the outermost electron will increase. Means if a positive charge is more, it will attract the negatively charged electron towards itself. So because of that, what will happen? This will shrink, and as a result it will get decrease in size. So if we increase the nuclear charge, increase in nuclear charge will decrease the size of atom. I hope this is clear to you all. We'll take an example for this. Sodium 281. Atomic number is 11, configuration is 281. So you can see from this configuration that this sodium wants to remove this electron to complete the octet. We know that an atom is stable only when it has 8 electrons in its valence shell. 8 electrons or 2 electrons. But here in this case, sodium has 1 electron in its outermost shell. So it is very difficult to gain 7 electrons to complete the octet rather than losing 1 electron. So it is easier to remove this 1 electron, extra 1 electron. If it will remove this extra 1 electron, then it will get a stable electronic configuration similar to that of neon. Neon is a noble gas. Here neon, it is a noble gas. It belongs to group 18. Atomic number is 10, configuration is 28. So what will happen? If this sodium will remove this extra electron, it will get an electronic arrangement similar to that of the neon. So it will become a stable species. So what will happen? It will remove this electron and become a positively charged ion, that is called sodium ion. This positively charged ion is called cation. Why it gain positive charge? Because we know that number of proton. See, atomic number is equal to number of protons, and number of protons is equal to number of electrons. That means if it is having 11 proton, that means 11 electron should be there. So, but what happened? One electron is removed. So now it is left with 11 proton and 10 electron. Its configuration is 2. So this is 11 and this is 10. So what will happen? The number of proton exceeds the number of number of electron. So what will happen? This nuclear charge, because it is more in number as compared to electron, it will exert a attractive pull towards this electron. So as a result, the size will shrink. So here sodium atom is bigger in size, smaller. Yeah, sodium atom is bigger in size as compared to its cation. Clear? Sodium atom will be bigger in size as compared to its positively charged ion, sodium ion. Now next we have to see next periodic property, metallic character. Metallic character. See group 1 and group 2. Group 1 and group 2 elements are metals. In group 1 except hydrogen from lithium, sodium, potassium, rubidium, cesium, francium, and group 2 beryllium, magnesium, calcium. This much is sufficient. You have to learn up to calcium, potassium. Okay, so these are metals. Why they are called metals? Because they have the tendency to lose electron. Elements that have tendency to lose electron are called metals. Just now we have seen the example of sodium. What happened in that case? Sodium lose one electron and becomes stable by getting the electronic arrangement similar to that of neon, its nearest noble gas. So what happened? Sodium belongs to group 1 and it is losing one electron. That means it is having the tendency, rest all the elements of this particular group will have the same tendency. They will lose, they all have one electron in their valence shell, so they will all lose one electron and become stable. So that is why these elements are called metals, because they lose electron, they have the tendency to lose electron. Similar is the case with group 2 elements. Beryllium atomic number 4, configuration 22, magnesium 12, 282, calcium 20, 2882. So you can see here that they all are having 2 electron in its valence shell. Group 2, that means 2 electron in its valence shell. So what will happen? To gain a stable electronic configuration, they will lose this 2 electron. So they are also having this tendency to lose electron. So they are also metals. Okay, now this metallic character also depends upon 2 factors. One is atomic size and second is nuclear charge. Now we have to see how these 2 factors affect the metallic character. This is the structure of sodium, and we know that sodium has 2 electrons in its first shell, 8 electrons in its second shell, and 1 electron in its valence shell. So what we want the easy removal of the valence shell electron. Why? To see whether this element is having metallic character or not, because for metal this valence electron should be removed easily. So if the size of atom is more, the distance between nucleus and the outermost electron will be large, then what will happen? The nuclear pull will decrease, and as a result this electron will get removed easily from this atom. So increase in atomic size favors metallic character. So increase in atomic size, there is an increase in metallic character. Nuclear charge. If there is an increase in nuclear charge means positive charge is more, it will attract the electron with greater force. As a result, the size will shrink and the removal of electron will become difficult. So as a result, metallic character will also decrease, because for metallic character we want the removal of electron, but here what is happening? Due to the nuclear pull, electron is getting attracted towards the nucleus with greater force, so removal will become difficult. So increase in nuclear charge will decrease the metallic character. Next is non-metallic character. Non-metallic character. See, the elements of group 15, group 16 and group 17, they are generally considered as non-metal. 15, nitrogen. First member is nitrogen, here oxygen and here fluorine. Nitrogen, phosphorus, arsenic, antimony, bismuth, oxygen, sulfur, selenium, tellurium, polonium, fluorine, chlorine, bromine, iodine, acetylene. So these are the group 15, 16 and 17 elements. So here they have the tendency to accept electron. We'll take one element, nitrogen, atomic number 7, configuration is 2,5, oxygen 8, to 6, fluorine 9 to 7. So you can see here that this nitrogen is short of 3 electrons to complete its octet. Oxygen is short of 2 electrons to complete the octet, and fluorine is short of 1 electron to complete the octet. So what they will do? They will accept the electron. So non-metals, they have the tendency to accept electrons. Again, it depends upon 2 factors: atomic size, nuclear charge. So now how the size of atom will affect the non-metallic character? For non-metallic character, we want the acceptance of electron, addition of electron. For that, the size should be smaller. And if the size should be smaller, then it will get attracted, the electron will get attracted towards the nucleus, and nuclear will favor the acceptance of more electrons in the shell. So what will happen? Decrease in atomic size will increase the non-metallic character. Decrease in atomic size, increase non-metallic character. An increase in nuclear charge. If we increase the nuclear charge, again it will attract electron towards it and it will increase the non-metallic character. So if we increase the atomic size, increase in atomic size favors the removal of electrons, so that we don't want here in non-metals case, we want acceptance of electrons. So we will decrease the atomic size. I hope these three properties are clear to you. Next three properties we'll see in the next video. Till then, bye-bye.